Here we go, 10.1a, lines.
Every non-horizontal line must intersect the x-axis. The angle formed by such intersection determines the inclination of the line. The inclination of a non-horizontal line is the positive angle theta less than pi, measured counterclockwise from the x-axis to the line.
All right, so theta is our inclination, and that's always a positive angle, and it kind of goes counterclockwise just like our unit circle used to do. All right, so we go from kind of like this x-axis, this positive x-axis, and we kind of move over. All right, now I want to talk about some special ones. If we have a horizontal line, what's the inclination? Zero. So zero, the inclination is 0. All right, if you have a vertical line, the inclination is pi over 2. All right, because it goes straight up and down. All right. Now, I want to talk about those a little bit more. What kind of line is theta equals 0? Horizontal. It's horizontal, which means it's a y equals. You following me? It's a y equals line. This is a what? An x equals a constant line. All right. If we have an acute angle, that means it has a what kind of slope? Positive. And if it has an obtuse angle, that means it has a negative slope. However, we'll talk about more of that obtuse angle and the differences between them. All right, let's put it in practice. So here's how you find inclination of a slope. So slope m is equal to tangent theta. I'm not going to give you that formula. You're going to know it. Okay, m is equal to tangent slope, tangent theta, where theta is your inclination. So I have this line. I have x minus y is equal to 2. And I need to find the slope of that line to then find the inclination of it. All right. So how do I find its slope on x minus y equals 2? What do I need to basically solve for? I basically need to solve for y. You following me? So what does y equal? X minus 2, right? But really, do I care about this negative 2 at all? Not really. All I care about is m equals what? 1. Okay? All I care about is the slope. I don't really care about the negative 2. We can solve for it, that's fine. But really all I care about is m equals 1 from that line. So now I have m, and I'm going to set it equal to tangent theta. So 1 is equal to tangent theta. We can do this in our calculator, and we're going to soon. But really, when does tangent equal 1? You guys know this from your unit circle. When does tangent equal 1? Pi over 4. So theta is equal to pi over 4 radians. Or how many degrees is that? 45 degrees. Okay. So that one we can do just knowing our unit circle on it. Okay. All right. Let's do another one together. Here we go. I have 2x plus 2y minus 5 is equal to 0. And I need to find the inclination of this line. Well, what do we need to do? We need to find its what? Its slope. All right, its slope. So, what's my slope? Okay, you want to solve for y? Let's solve for y. What does y equal? Negative x, and then? It's really going to be plus 5 halves. All right, now, do I really care about that 5 halves? I don't care about it. All I care about is m equals what? Negative 1. That's really all I care about extracting from it. So now I say negative 1 is equal to tangent theta. And I need to solve for theta. So this is actually on my unit circle. When does tangent give me negative 1? No. 3 pi over 4. All right, 3 pi over 4 radians. Or how many degrees is that? That's 135 degrees. All right. It's always it's between 0 and pi, or 0 and 180. All right. Now, I want to do this one in your calculator. So how could I actually solve for theta? We can arctan it. So we're going to arctan both sides. So theta equals arctan of negative 1. Now, if you're in degree mode, make sure you're in degree mode. What does theta give me? Theta equals what, according to my calculator? it gives me negative 45 degrees. Now, that is not the correct answer. That's not what I want. Because which way did negative 45 degrees go? That went clockwise. Well, the angle that we need for inclination goes counterclockwise, and it's always between 0 and pi, or 0 and 180. Is negative 45 doing that? No, the calculator gave it to you. It's not necessarily wrong, but it's not right either. So what do we have to do to this negative 45 degrees? We add 180 to it. And so then we end up with 135 degrees. Are you following me? Mm-hmm. Does anybody remember why it has to be a negative 45 degrees in my calculator? Has to do with that domain and range thing. Remember? Okay? It can't keep going past it. Okay? The range of arctans between negative pi over 2 and pi over 2, that's why it does that. All right? So now we got this one. We got 2x plus 3y equals 6. And I want to find the inclination both in degrees and radians again. Well, what do I care about on this line? I care about the slope. So what would be my slope? Negative 2/3. It's really all I care about from it. Okay? So now that we have negative 2/3, now we say negative 2/3 is equal to tangent theta. Now, is this one on my unit circle? No. So I have to have a calculator here. So I'm going to arctan it. So now I have arctan of negative 2/3. And what do I end up getting? 33.69 degrees. All right. Well, what do I need to do to that? I need to add 180 to it. All right. I would not give you full credit if you gave me that answer. All right. So we're going to add 180 to it. So we end up with 31 degrees. So there is my inclination in degrees. Now, I also want it in radian mode. How do I convert from degrees to radians? We multiply by pi over 180. So we multiply by pi over 180, and we end up with 2.5536 radians. All right. All right. There we go. Pretty good. I'd like you to do this one. So find the inclination in radians and degrees of 2x minus 2y plus 8 is equal to 0. Me out. What's my slope?
1/3.
Nope. All right. 3. My slope is 3. All right. If you get your slope wrong, guess what's going to happen? Everything's going to be wrong. All right. So let's make sure that we can add 2 and divide by 2 kind of thing. So anyway. All right, so we got m is equal to 3. So now we end up having tangent theta is equal to 3. And so theta equals 71.57 degrees, or how many radians? 90 radians. All right, pretty good in the hood. All right, let's keep moving. I need a reader. Thank you so much, Jacob, for volunteering.
Two distinct lines in a plane are either parallel or intersecting. If they intersect and are non-perpendicular, their intersection forms two pairs of opposite angles. One pair is acute and the other pair is obtuse. The smaller of these angles is called the angle between the two lines.
All right, so any two intersecting lines that aren't perpendicular, they form these angles. All right. And so I'm basically going to refer to the black angles and the red angles. Hopefully we're not going to find out on the video. But these two are going to be the same, true? Why are these two going to be the same? Because of, if I remember geometry, they're vertical angles. They're vertical angles. All right, Katie Shinley. And then these two are also going to be the same because they're also vertical angles. Now, this formula is going to be called the angle between the two lines, is always going to solve for the smaller of the two angles. Every single time it's going to solve for the smaller of those two angles. All right, so it's always going to solve for, like this, in this case, the black angle. All right, It will not solve for the red. Now, how could you actually solve for the red? You can subtract whatever you get from 180. All right? And so it's always going to solve for the smaller of those two, and that's really how it works. Now, I don't need you to memorize this unless you're on A-team, because it comes up every now and then. But here it is. So tangent theta is equal to the slope of one line minus the slope of the other over 1 plus the two slopes product. And it's all under the absolute value bars. All right. Why is it in absolute value bars? Because it doesn't matter which one comes first. All right. That's why it's that case. All right. All right. So please write it down, but you'll just need to know how to use it. Good, good. All right. Here we go. So I have line 1 and line 2. Line 1 is 2x minus y minus 4 is equal to 0. And line 2 is 3x plus 4y minus 12 is equal to 0. Again, what do I care about on these lines? The slope. It's all I care about. Okay, I don't care about anything else on it other than the slope. So here we go. So what's my slope of this first one? 2. My slope is 2. What's the slope of this one? Negative 3/4. All right. If you don't get that right, it's not going to be right. Okay. So now I'm just going to use my little formula. So now I have tangent theta is equal to, which one do you want M2 to be? I don't really care. The second one. So now I have negative 3/4 minus 2 over 1 plus 2 times negative 3/4. All right. So I just used the little formula. See how that worked? Now, I personally would do some math before I start arctaning this. Okay? It's going to be a lot of calculator work if you try to do it this way. All right. So now, how do I want to think of this negative 2? Negative 8 over 4. All right, so a negative 8 over 4 with a negative 3 over 4 ends up being what? Negative 11/4. All right, negative 11/4. And then 2 times negative 3/4 is what? What is it? Negative 6/4. Okay, so now we have negative 6/4. And then 1, how do I want to think of 1 as? 4 over 4. All right. So I have negative 11/4 over what? Negative 2 over 4. Well, what happens to my 4s? They cancel. That's convenient. So now I have negative 11 halves. Negative 11 over negative 2. But really, do I care if either one of them is negative? Not at all. So what do I end up getting? 11 halves. Now, some people on the test actually leave it right there. That's wrong. What do we need to do now? We need to arctan it. All right. So now I arctan it. So I end up with theta equals all right, 79.69 what? 52, so 70. All right. Or how many radians? Multiply by pi over 180, and we end up with 3909 radians. All right. All right. So it's solved for the smaller of those two angles. All right. All right. I'd like you to try this one. I want you to find the angle between the lines and radians and degrees of these two. Julian's going to help me. What's my slope of my first one? 1/2. All right. And what's my slope of my next one? Negative 3. All right. And so now we end up having tangent theta is equal to?
Negative 3 minus 1/2. And then on the bottom, 1 minus negative 3 times 1/2.
1 plus negative 3 times 1/2. All right. All right. So then how do I want to think of negative 3? I want to think of that as negative 6 halves. So negative 6 halves. And then minus 1/2 is really negative 7 halves. And then I have 1, but really I have negative 3 plus 1/2, or times 1/2, which is negative 3 halves. So how do I want to think of this 1 as? 2 over 2. And so now I end up having negative 7 over 2 over negative 1/2. Now, this one ended up being positive to begin with. However, I end up with a positive 7. And so now I have tangent theta is equal to 7. So what do I have to do to that 7? I arctan it. So theta is equal to 8 what? So 8.7 degrees, or how many radians? 8.9 radians. All right, pretty good. Again, all we have to do is extract the slope. All right, so this is, I think, the first one on your homework. Now, this one says theta is equal to pi over 6, and I need to find its slope. We haven't done really one exactly like this, but what's that one formula that I need to know? M is equal to tangent theta. Well, it gives me a theta here, so it's actually easier. So guess what I have to do to it? Tangent that. All right? And so now I have tangent of pi over 6. You guys have noggins too. What is the tangent of pi over 6? The tangent of pi over 6, the y over the x. Square root 3 over 3. So my slope is square root 3 over 3. All right. If I put that in a calculator, first of all, what mode does that have to be in? That has to be in radian mode. All right. All right. There you go. Page 730, numbers 5 through 25 odd, and 28 through 44 even.